when we are aware of the opportunity of SAFMC competitions under this autonomous category, I decided to form a team of 4 to take care of the different aspects of the drone technology. And we need someone, for example, who is good at control, mathematics, visions, hardware skills, and with good piloting skills.
I'm Jing Chai from the Diploma in Aerospace System and Management.
Hi, my name is Edwin. I'm a Year 3 student from Diploma in Aerospace System and Management.
I'm Grace and I'm a second-year Aerospace Systems and Management student.
I am Jing Kai, a third-year Aerospace Systems and Management student.
Hi, my name is Jing Feng. I'm from Diploma in Aerospace System Management, Year 3.
Hi, my name is Gan Anzhi. I'm a lecturer in Nanyang Polytechnics.
I am in charge of the autonomous flight control, which is basically the flight movement of the drone.
I'm in charge of image processing, including marker detection and obstacle avoidance.
I'm responsible for data presentation, user interface, and Aruko marker.
I am responsible for the algorithms of the formation and interactions of the drone network.
I'm basically responsible for building, piloting, and hardware implementation of the drones.
I am the team supervisor.
We use the robot operating system as our main robot software development. And we also use Gazebo as our simulation software for pre-testing and for proof of concept.
So, firstly, I've created a mock-up competition arena in Gazebo simulation. This is to ensure the programs that we have done are simulated as close to actual scenarios as possible.
OpenCV is a library of programming functions mainly aimed at real-time computer vision. We use that to mainly track and display drone status, the position, and orientation of the drone. Additionally, we also trace the markers for its current and next position.
The leader drone will detect the markers to execute the movement according to the marker's position and orientation. Additionally, we need to use the markers as a checkpoint for loading and unloading of payload. And as for the D435i, it's a forward-facing camera used for obstacle avoidance.
For marker detections, we used image processing method to obtain the relative position of the drone with respect to the marker. For obstacle avoidance, we generate the point clouds from the forward-facing D435i camera and use 3D VHF plus algorithms to calculate and generate the path to avoid the obstacles.
Visual Inertial Odometry, which in short stands for VIO, is a computer vision that provides position and the velocity of a moving vehicle even when GPS is absent or unreliable. This is exceptionally useful as we will be operating in an indoor environment.
We have one server communicating with both drones simultaneously, in real time. Both drones also exchange data between each other to maintain the network's formation. There are two main considerations for the UAV network. The first is how the drones use available information for position and velocity, and the second, how the networks maintain information. We use a state machine to design our control algorithms. We cater different states for different actions.
For example, having the drone hover while loading the payload, then to moving through obstacles, or aligning its positions with visual aids.
In order to maintain accurate information, we use the markers to calibrate the drone's relative position in real time.
Prior to testing autonomous flight, we need to ensure that the drone is configured according to desired conditions. We chose a quad-quarter layout as it is easier to interface and overall more efficient for executing missions. We need to ensure clean solder joints, perform continuity tests before performing manual test flights. We use a radio transmitter which communicates with a receiver, which allows us to control the drone manually as well as to start autonomous flights. Pixoc 4 or PX4 is an open source flight controller which allows us to easily interface and perform autonomous flight. We use Q-Ground, which is a ground control station which allows us to calibrate a flight controller, enabling sensors for interfacing and calibration of the onboard IMU.
The Jetson Nano is an onboard computer that allows us to store as well as to run the programs that we want.
We have to ensure that the Jetson is communicating with PX4 via UART prior for flight.
For unloading the payload, we came up with a strategy of varying the altitude of the drones to tilt the payload carrier for ease of unloading. This competition enabled us to think out of the box, apply problem-solving skills,
Improve our communication skills and technical skills.
the skills that we learned through this competition will definitely have great impact on our future.
This competition allowed me to have a deeper understanding of the processes involved in developing projects and implementing systems. I learned many things that I never thought I would through programming and problem solving.
This competition enabled me to go out of my comfort zone, brainstorm, and come up with innovative solutions for the problems I faced. The skills I learned will definitely be impactful in the future.